Today we're going to be talking about diffusion. Diffusion is basically, I know we all have tried it. We all do it every single day. Every time you make tea or coffee for yourself, you throw in some hot water, and then the hot water dissolves within that coffee granules or tea bags, right? So diffusion occurs in a solid, a liquid, and a gas. In a solid, if you take a cube of sugar or even coffee granules and you put it within your hot water and you stir the hot water, then the particles of the solid will move in the spaces between the particles of the solution. The solution is the water that's already there. All right. Same with the liquid. If you take some food coloring, and I know we all had done this as well, where we drop droplets of food coloring within a glass of water, and after some time, if we don't stir it, it's going to dissolve itself and equally space out in that container. Okay. Sometimes it sits at the bottom, and you just need to give it a little stir. But with a gas, the gases are most amazing because they will diffuse to all spaces within the available space, right? So we don't need to like make that happen. It just happens. If you're cooking, all right, and your liquids evaporate from the food, then very easily on one end of the room someone would be able to smell it, right? Because the gas travels, the vapor and the smell travels. Okay, so just a quick definition of diffusion. Diffusion is the movement of particles that allows them to spread out and mix with other particles in a space. Okay, so this is the definition that you need to know for your exams. And we look at diffusion in gases because gases have the highest kinetic energy. Guys, what is kinetic energy? Tell me in the chat. We have heat energy, we have many kinds of energy, potential energy, but then we also have kinetic energy. We have chemical energy, like we learned in photosynthesis. Yes, so Sarah says it's movement energy, exactly, all right? So gases, particles of a gas have the highest kinetic energy. That means that they move the fastest and they have the most energy to move, right? Gases diffuse the fastest because the particles spread out and mix with other particles in the solution quicker. Okay, so it's not necessarily in the solution, it can be in the atmosphere as well. And Quentin had a very good question yesterday. He asked me, is Quentin here? Yes, Quentin is here. He asked me, what about perfumes? Like, isn't perfume a liquid, and how can we say that it's a gas? So guys, what happens is that although perfume is a liquid in its bottle, as soon as you spray the perfume or leave like a perfume bottle open, because it contains a large amount of alcohol, the surface of the liquid, those particles will gain a lot of kinetic energy. Okay, and when the particles gain kinetic energy, the liquid starts evaporating, but only the surface of the liquid. Think about if you've ever left a perfume bottle open, or you've left a perfume bottle open, and after some time you'll be able to smell the perfume in the surrounding areas. Okay, even something simple like coffee. Right, coffee is a very strong, pungent smell, right? So if you look at the surface of the coffee, the surface is like right on the top, right? That layer. What will happen is that the particles on the surface will gain kinetic energy, and when the particles of a liquid gain kinetic energy, which is movement energy, then it evaporates, right? It changes from liquid to a gas. Okay. All right, so this is basically a diagram of how diffusion works. You drop a little bit of, for example, this is food coloring into some water, and the red is the food coloring. And can you see that over time, particles of the food coloring will mix in between the spaces of the water And that's how it will be evenly distributed within the final solution. That's how it's going to be diffused. Okay, moving back to the gases. Gases always fill up the available space. Okay, so it's not like a liquid or a solid where it only fills up that container or that the water in the container. A gas will fill the entire room, okay, because it has the most kinetic energy in the particles. An example of a gas is the smell of aftershave, all right, perfume, food cooking on a pot, and food that all of those smells diffuse within the atmosphere around you and can be detected by people on the other side of a room. Then we have diffusion of solids, right? So solids, as I mentioned before, like coffee granules or cubes of sugar. Can you guys think of other solids that we diffuse? I'm trying to think of things that diffuse. Maybe salt and water. Salt is also a solid. Powders like, you know, Nesquik or hot chocolate. Those are also solids, right? And they also diffuse in water. Okay, so diffusion in solids can only occur if the solid is able to break down in a solution. Marcus says chlorine. You mean chlorine that we use in our pools? Yes, if you're talking about diffusion of a liquid, then it is chlorine. When we add pool acid into a pool, right, then that liquid diffuses between the particles of the water in the pool. Yeah. So right, and lastly, diffusion happens a lot faster in hot temperatures than cold temperatures. Think about when you just drop some sugar in a really cold water, right? It's going to take a very long time for the sugar to actually dissolve move within the particles of the water and become one with the water, right? But as soon as you add it to piping hot coffee or tea, the sugar can quickly diffuse because what happens is that the heat energy from that water transfers to the particles of the sugar, and heat energy is transferred into kinetic energy. So we move from heat energy to kinetic energy, because remember that, I'm sure you learned this in grade 5 or 4, whatever, that energy can never be created or removed, right? It can never be lost. It is always transferred, which means that it moves from one type of energy to the next type of energy, right? So when I heat my coffee or solution, then I add my sugar, and the sugar gets heat energy, right? But it doesn't get hot per se. It gets the energy to move faster. And when it starts moving faster, then it will be able to fill in the spaces of the liquid, just like this picture, right? But if it's cold, if the water is cold, then the particles will take a little bit longer to fill in the gaps between the particles of a liquid and evenly distribute, right? Yeah, so this is because heat energy converts to kinetic energy when transferred to the particles. This causes the particles of a substance to move rapidly within the spaces of a solution. When something moves rapidly, it's moving fast in all directions. It doesn't have this particular system. And lastly, another way to give your solution or to give your substance energy is to physically stir the contents of a solid or liquid. So if I drop some food coloring into water, right, then I take my spoon and I stir the contents. It will make it easier for those particles to move in between the spaces of the solution. A solution, by the way, is like water or liquid, all right? A solution is when you take a salt, and a salt could be just say any substance, and you mix it with water, which it becomes a solution. Yes, Tendo, as long as you can catch the replay afterwards. All right?
Yes, ma'am.
Okay. All right. Did you hear what I said?
Yes, ma'am, I heard.
Okay. All right. And then, yeah, so guys, that's basically the lesson for today. And I hope you guys understood. For tomorrow, right, you guys are writing your NS paper. And I'm just going to give you a quick brief on how we're going to go through with that, right? So I'm going to post your test onto Google Classroom just in time, all right? And Marcus, I will email it to you. And then, guys, you need to upload the document onto Word, all right? If you don't have Word, actually, you should all be having Word, but I'm going to make it, I'm going to send a PDF as well, right? So if you don't have Word, you can still, does everyone have Word? Tell me in the chat.
Yes, ma'am, I have Word.
Okay.
Me too, ma'am.
All right, so it looks like everyone has Word. Awesome, awesome. So what you can do, right, if you want to write your answers down, then you can do it on a piece of paper. You can just write your answers. And if you want it to be neater, if you have a printer, you can scan your answers and then send me the scanned version. Or you can upload the Word document and write your answers on the question paper. Right, if that's easier for you, or you can just create a new Word document and write your answers on there. Okay, I think what you should do is create a new Word document and write your answers. If there are questions to do with drawing, I may ask you to draw an atom, right? Then you can draw on Microsoft Word. It's very easy. So you just go into shapes and you'll just be drawing like circles basically. Right, basically like that. And yeah, you can do that. Or if you don't feel comfortable with working with Word, then you can just write your answers down on the script and send me the scanned copy. Or if you're taking a picture, it needs to be neat. I need to be able to see the entire text. All right. And lastly, I'm going to give you guys, like, if the test is 30 minutes, then you have about 30 minutes to complete the test, and then 10 minutes to upload your test. If you're emailing Marcus, you'll email it to me. The rest of you need to upload it onto Google Classroom. Okay, so not Google Drive, Google Classroom. And I'm just going to go through that to show you how you can submit something on Google Classroom just in case. Yes?
I found a way to, because my phone, it's not really compatible with Word or Google Classroom. I found a way how to post things on Google Classroom. I just need to email it to myself and then download it as a document and then post it like that.
Oh,
so I will be able to in Google Classroom.
Oh, awesome, Marcus. That's really savvy of you, right? Thank you. It's gonna make our lives easier. Right, so I'm just logging in as a student into Google Classroom so I can show you guys what I mean. So for example, it's grade 7 English, right? And I posted the book review, for example. Right, so this is what you'll be able to see on your screens. Okay, and I'm going to give you the instructions over here. I'm going to attach a Word document there, and then all you guys need to do is add or create a document and then choose where you want to upload it from. Upload it from File or Google Drive or wherever. One awesome thing you can do is you can go into Docs and it creates a Google document for you. So Google document is just a blank page, and you can also write your answers on there. Right, so it will take you to something like this. Right, and then you can just add in your answers. Okay, if you don't want to work on Microsoft Word, that's fine. Okay, if you're taking a picture, you can also edit on Google Classroom. You just need to, you can do it on your phone very easily, and then you just go into File, and it will show you a gallery option, or you can literally take a picture on your phone by clicking Add to Create as well. All right. So guys, all the best for tomorrow's paper, and I hope you guys all know what to learn for the paper. I have added a breakdown. Alright, so it's basically all the stuff we went through before going on to the particle model of matter. You don't need to learn the particle model of matter. Yeah, so you need to learn elements, compounds, mixtures, the difference between pure and impure substances, atoms, drawing the atoms. You need to know your 20 symbols from the periodic table. You need to know those elements. So I'm going to ask you to write them down. I'm going to ask you to write the symbol or maybe sometimes the name, and you need to know the 7 diatomic molecules. I have no fear of ice cold beer. And yeah, if you have any questions, please ask me before the test. Okay, any questions now? Anything I can help you guys with?
No, ma'am.
Okay.
No, ma'am.
All right, awesome. How are we going to do the test? So, Tendo, just like how I explained now, you're going to download the test from Google Classroom, and then you can either write your test physically, right?
Ma'am, not like that. I mean, like, is it gonna be also on Zoom? Are we gonna do in Zoom and do it on the laptop, or we're not gonna have a Zoom class and just do it on Google?
Yeah, no, very good question. We're not gonna have a Zoom class, all right? So it is so guys, you shouldn't refer to your notes. You should take it strictly as a test paper. Okay, obviously that's now a trust thing, so you guys need to make sure that you don't look at your notes. Yeah, but think of it as, I mean, that's how I do my tests and stuff through my university, right? So I don't need to be checking on you on Zoom. For more like official tests, like exams and stuff, that's when I'll check on you. All right. Okay.
Yes, ma'am.
Yeah, and then you must hand it in within the next 10 minutes of finishing your paper.
Ma'am, what if we finish earlier? Then
Then
can